Hey, thanks for coming back to Rithmetic with Ron. How do we turn a fraction into a decimal? Well, today we're going to look at that together. Go ahead and hit subscribe and enjoy the video. Let's begin today's lesson by quickly reviewing how we can take a fraction and write it as long division. Okay? What we want to do is recognize that we can write or read this problem, this fraction, two different ways. As a fraction, this says 2/5. That's as a fraction. But if I read this like division, it says 2 divided by 5. Okay? So what we're going to do to convert fractions to decimals, we're going to take our fractions and we're going to read them as long division. Let's go ahead and see how a fraction problem lines up to long division. Okay, the numerator is going to go on the inside. The denominator is going to go on the outside. 2 divided by 5. Okay, if it's helpful, I'm going to write out the parts of a fraction and long division labeled so that you can see. As you can see, in a fraction, you have a numerator, a denominator, and a quotient. And in long division, this is how the parts of a fraction are rearranged. Now, in long division, there are different names for these, and I'm going to go ahead and write them out now. And here we can see that in long division, we have a divisor, a dividend, and a quotient, but this is how the parts of a fraction and long division are connected. Now that we've seen that, we're going to erase this and talk about how we actually do this problem. Let's keep our same example of 2 divided by 5. Let's go ahead and solve this. 2 divided by 5. What we're going to do is recognize that 5 is bigger than 2, and so I'm going to have a decimal in here. All right, I'm going to put my decimal and a 0. This is still the number 2, but I've given it a value in the tenths place. It looks different, but it has the same value as 2. It's very important when you do long division that you keep the decimal in your quotient directly above the decimal in the dividend. It's just like place value. You want to keep ones places lined up, you want to keep tenths places lined up, and you want to keep the decimal lined up. Let's go ahead and solve this. 5 goes into 2 0 times. You can't fit 5 into 2, so it doesn't fit at all. You have a 0. 5 times 0 is 0, and we do our subtraction. We're left with 2, and then we're going to bring down this next 0. How many times does 5 fit into 20? It fits in 4. 5 times 4 is 20. I do my subtraction, and I'm left with nothing, and I've used all my digits up top. Okay, so the final answer here is 0.4. Let's go ahead and take a look at another example with some slightly bigger numbers. 65 divided by 100. As a fraction, that's 65 100ths. What we're going to do is rewrite it as a long division problem. 65 divided by 100. Okay? Now what we want to do first is we're going to put in our decimal and add a 0. This is the same number as 65, but I've added a decimal and a 0, and it's not a different value. We've just carried out more place values. And the first thing we want to do is move that decimal point up into the quotient. You need to keep these right above each other. By doing that, as we do this long division problem, we can ignore the decimal now because we've taken care of it. And we can just treat this like regular numbers. 100 does not fit into 6. It goes in 0 times. So let's do the math. 100 times 0 is 0. We're going to subtract and get 6 and bring down the 5. 100 does not fit into 65. 100 times 0 is 0. We do our subtraction. Now we're going to bring down this next 0, and we get 650. 100 goes into 650 6 times. We multiply and we get 600. Subtract. We have 50 left over. And now I'm going to add another 0 because I've used this 0 and I still have a number left over. Remember that I said you can add as many zeros as you need until you finish the problem. Let's go ahead and bring that 0 down. And 100 goes into 500 5 times. 5 times 100 is 500. We subtract, and I have nothing left over, and I've used all the values. So the final answer up here, let's go ahead and rewrite this. Let's go 0.65. All right, let's take a look at another example like 8/32. That's the fraction. We are going to convert it into a long division problem by writing 8 divided by 32. Let's go ahead and put in a decimal and a placeholder 0, and we're going to move that decimal up into the quotient right away so that it's in the proper place. And now we can do this division without worrying about the decimal. We can just look at the numbers. 32 goes into 8, not at all. So we're going to do this. 32 times 0 is 0. We subtract and we get 8, and we bring down the next 0. 32 goes into 80 2 times, and now we do the multiplication. 32 times 2 is 64, and when we subtract, we get 16. We don't have any more zeros, so I'm going to add another 0, and I can bring that down. And now, how many times does 32 go into 160? It goes in 5 times. 5 times 32 is actually 160. So now we've used the zeros that we had and we added the ones necessary. Because 5 times 32 is 160, when I subtract, I have nothing left over. And so the final answer, 8/32, we wrote it as a long division problem. We put in the decimal, carried it up top, and added the zeros that we needed and did the long division. And our final answer is 0.25. Let's go ahead and do a different kind of problem where we have a new issue that comes up. We're going to look at the fraction 5/9, and we want to turn it into a decimal using long division. Let's go ahead and write it out as long division. 5 divided by 9. Just like before, we're going to put in a decimal, a placeholder 0, and we're going to move that decimal up into the quotient right away so that we keep our place values in the right spot. And let's begin. 9 does not fit into 5, so we have a 0. We multiply and get 0. Go ahead and subtract. Bring down the next 0. Okay? 9 goes into 50 5 times. 5 times 9 is 45. We subtract, and we have something left over, so I need another placeholder 0. Let's go ahead and bring that down, and I get 50. Wait a minute, I just had a 50. What do? We do the same thing. 9 goes into 50 5 times, and 5 times 9 is 45. This is looking kind of familiar. Let's go ahead and subtract. We have 5 left over, so we need to add another placeholder 0, and we bring that down. And look at this. I've had 50 again and again, and this is going to go on forever. This is called a repeating decimal. And if we kept on doing math all afternoon long, we would just keep adding 5s forever and ever. Now, we're not going to write 5s forever and ever. What we're going to do is use something called a repeating bar. That's a bar that you put above the part of the decimal that repeats forever. In this case, because it's just 5s, we're going to put it over the first 5, and we can erase the rest of them if we want to, now that we've seen the pattern. And what we're going to say is that this is our final answer. 5 divided by 9 is going to be 0.5 repeating. Again, that bar is placed above the digits that are repeated over and over again, and that means that the 5s go on forever. Since we don't want to write it that way, we've got a math symbol that tells us what's happening without taking up all that space. What do you do if you have a decimal that has more digits that repeat than just one? Let's take a look at that now. With the fraction 1/7, we want to turn this into a decimal. So we're going to write it as long division. Just like before, we're going to put in our decimal and a placeholder 0. And we're going to move the decimal up into the quotient right away so that it's in the right place and we don't have to worry about it. Let's go ahead. 7 does not fit into 1. 7 times 0 is 0. We subtract and we bring down the next place value. 7 goes into 10 once. 7 times 1 is 7. We subtract and we get 3. And now I need another place value. So I'm going to add a 0 and I'm going to bring it down here. And 7 into 30, well, that's 4 times. I multiply 7 times 4 and I get 28. I subtract and I have 2 left over. Since I have something left over, yeah, I need to add another place value. Let's go ahead and bring down the next 0. 7 goes into 20 2 times. 2 times 7 is 14. We subtract and we get 6 left over. Since I have something left over, let's add a 0. Bring that all the way down. And 7 goes into 60 8 times. Let's multiply those. 7 times 8 is 56. I subtract, I get a 4. Since I have something left over, I'm going to bring down the 0. 7 goes into 40 5 times, and I get 35. And I have 5 left over, bring down a 0. And 7 goes into 50 7 times. 49 is 7 times 7. And so I'm running out of space here. Let's go like this. We had 50. 7 times 7 is 49. When I subtract them, I get 1. Now, when I get this 1, I'm going to have to bring down another 0 from right here. When I do that, look at this 10. This is what we had all the way back in the beginning. And that process all the way down here is going to repeat itself. So our digits right now are 0.142857, but now that whole process is going to start all over again. 7 goes into 10 1 time. And look at, we had a 1 here, and now the process is starting over and it's going to repeat itself. So we are going to put the repeating bar above all of this. The digits from 1 through 7 are going to repeat again and again and again. There's the second batch. If we were to do this math, we would get a third batch. Well, we don't want to write out decimals forever. So the final answer here, we're going to say 1 divided by 7 is 0.142857, and the repeating bar is going to go over all of that, which means that these digits will repeat again and again in a row in that same order. Well, today we learned how to take fractions and turn them into decimals. Hope you enjoyed the video. Go ahead and leave any comments or questions. Hit subscribe, and we'll see you next time.